All right, so today we're talking about the greatest common factor. I think most of you have heard of it before. You have an idea what it is, and you know some purposes for it. And we'll get into that more later. But today I'm really going to focus on how to find it, the easiest way that I know of. There are multiple ways to find the greatest common factor, but the one I'm going to show you works every time, and it works for multiple things. So I think you're really going to like it. You just wrote down the definition and glued it in on page 8. The definition is the largest factor of a set of numbers. Okay. So for the numbers 18 and 22, the greatest common factor is 2. That is the biggest number that divides evenly into both of those numbers. That's what we're looking for. When we say greatest common factor, it's the biggest number that divides evenly into a set of numbers. All right, so to find the greatest common factor, you're going to do these steps, and this is what you just cut out and glued down. So it says how to reduce and find the greatest common factor with the ladder/cake. I call this a cake because I think it's more fun. Miss Cuneo calls it a ladder because she's a little bit more lame than I am. But in any case, when you see ladder or cake, this is what we're talking about. Okay? So the greatest common factor is the product of the numbers on the left, and to reduce, you use the bottom two numbers to create your fraction. Hold those thoughts in your head, because that probably doesn't mean anything to you yet until I've shown you what it looks like. But just keep this in your mind that these are what we're doing. We're going to go straight into it, okay? So it says, what is the greatest common factor of 9 and 15? So this example I'm going to do, I just want you to put your hands down and just watch for a minute. This can also be, greatest common factor is used for reducing fractions. So there actually are two questions on here. It says, first of all, what is the greatest common factor of those two numbers? And then it says, how do you reduce it if you have that as a fraction? We're going to do it the same way. That's why I put those two things together. So the first thing we're going to do is make what I call the cake. I call it a cake because it looks like an upside down cake. So we wrote our numbers 9 and 15. And then we drew something like this. This looks kind of like an upside down division sign, right? Like the upside down house, okay? Because it's kind of about dividing. That's what makes it easy. So if we looked at the numbers 9 and 15, and I asked you, can you think of a number that divides evenly into 9 and 15? What would you tell me, Nathan?
3.
Nathan says 3 divides evenly into 9 and 15. He's correct. And it doesn't matter what number we start with. So if you saw another number that divided evenly into these numbers, you could use a different number. Okay, as long as we pick one number that divides evenly into both 9 and 15. And we said that the number 3 divides evenly into them. So we write it here next to it, 3. That's saying I'm going to divide 9 and 15 by 3. You're not writing this yet, you're just watching, okay? So 3 divided into 9 goes how many times? 3. 9 divided by 3 is 3. So 3 into 9 is 3. How about 3 into 15? 5. Okay, do you see what I just did? I just divided the number that went into both of them. I divided it into both of those numbers. Okay, and now I have 3 and 5. Is there a number that divides evenly into both 3 and 5? Be careful before you answer. I see lots of no's. Anybody have a yes? You have a yes, Emily?
1.
Yeah, 1, okay? And I know some of you are like, well, that wasn't fair because 1 divides into every number. That's true, but the whole point is that if 1 divides into it, we're still going to write a 1 right here. When we see the 1, that means we're done. We are finished dividing. There are no more common factors between 3 and 5. So it's finished. So the greatest common factor is what's on the left. So we're going to circle it. It's these two numbers multiplied together.
3.
Listen, don't say anything. Listen. So the greatest common factor is 3 times 1 or just 3. Now, I'm not going to ask you to write out 3 times 1 every time because that doesn't matter. But I did that just to show you that's how I got it. I got it from the numbers on the left. And then to reduce the fraction, this is my favorite part actually. To reduce the fraction, we've already reduced it because we divided it by the greatest common factor, which was 3. So your reduced fraction is this, 3 over 5. So to reduce 9/15, we have 3 over 5. All right, so if you will write on your paper these two numbers, 24 and 36. We're going to do this one together. Go ahead and draw, this is what I call the cake. Oops, that is not going to work. Hang on. Let's try that again. So this is the cake. This is the bottom layer, if you will, of the cake. So we have to pick a number that divides evenly into 24 and 36. Now, some of you are going to pick a bigger number than others of you will. So I'm going to start, when we're doing this together, I'm going to always go with the smallest number. However, if you see a bigger number than the one I use, it'll still give you the same answer. That'll make more sense in just a second. So Dasani, can you tell me the smallest number besides 1 that goes into 24 and 36? What number were you going to say? Because you had your hand up.
6.
You were going to say 6? Okay, what's smaller than that, Cameron?
2.
2. 2 is really the smallest number besides 1. So 2 goes into 24 and 36. Again, Dasani's answer was not wrong. You could use 6, but for purposes of example, I'm going to start with 2. So how many times does 2 go into 24? 12 times. And how many times does 2 go into 36? 18. Good. 18 times. Okay, and then we ask ourselves again, do 12 and 18 have a common factor?
Yes.
Yeah, what is it? 3. Okay, how about 2? Can we do 2?
Yes.
Okay, so 2 is a common factor. 3 is also true, and we could have used that, but I'm going to use the smallest for the example. So we're going to divide it again. 2 goes into 12 6 times. 2 goes into 18 9 times. Do we still have a common factor between 6 and 9, Emily?
Yes.
What is it?
3.
3. Good. No more 2s right now. We're on 3. 3 divides into 6 how many times? 2. 3 divides into 9 how many times? 3. Okay, do you see? Every time we're just dividing a different number in. Now, 2 and 3, do they have any common factors besides 1?
No.
No. So put down the 1, and when we see the 1, we are done. 1 and done. Now, here's where some of you might make a mistake, so stay with me. Okay, our greatest common factor is all of this put together, but how do we put it together? We multiply it. We multiply it. So, I'm going to write it out here. It's 2 times 2 times 3. I'm going to leave off the 1. Are you okay if I leave off the 1? Because you know that it's there and it's just not going to change the number. So 2 times 2 is 4. 4 times 3 is 12. So the greatest common factor of 24 and 36 is 12. And if we were going to reduce the fraction 24 over 36, we would take it, divide it by 12, and we would get 2 over 3. So our reduced fraction is 2 over 3. Okay, write this one 12 and 20. You can use the back of page 8 if you need to. Go ahead and see if you can make the cake without my help. Now, just a hint, you can use the smallest number, or if you see a bigger number, you can use that. All right, so how many people saw a number that divides evenly into 12 and 20? What number did you see, Johan? 2, okay. And there is another one you could have used, but I'm going to do the smallest, which is the one that Johan just gave us, which is 2. Okay. How many times does 2 go into 12? 6 times. And how many times does 2 go into 20? 10 times. Okay, now, we look at that. Is there still a number that divides evenly into both of them? Yeah, there is. What is it? You can say it. 2. 2 again. So 2 goes into 6 3 times. 2 goes into 10 5 times. Is there still a number that divides into 3 and 5? Only one. Very good. There is a number, but it's only 1. 1 and done. So we're finished. So our greatest common factor is 2 times 2, which is?
4.
How many people got 4 on their paper? Excellent. Okay. How many people reduced the fraction? Good. Caroline, what did you get? Yep, 3 over 5. And remember, Remember, it comes from right here. 3/5, 3/5. That's our reduced fraction. It is easy. And what I love about this too is that, if you've had trouble reducing fractions, I always had trouble because I could never figure out if I was at the very smallest number. That was what always gave me the most trouble. I could reduce a fraction, but I might not reduce it all the way. But this way, once you look at it this way, it's really easy to know if you've reduced it all the way. It's one reason I really love this. So on your paper, work 35 and 70. Okay, so far we have 5 into 35, then we have 7 into 7, and 7 into 14. Okay, so our greatest common factor, remember, is these two multiplied together, which is 5 times 7, which is 35. I forgot to finish that, sorry. Let me write my 1. Equals 35, and our reduced fraction is 1/2, 1/2. All right, this is our last one we're going to do together of this kind. So go ahead and do this one. All right, so how many of you know what to do, and how many of you are like, I don't really know what to do with that? Some of you are kind of like, I don't really know. That's okay. All right, so what is the problem with this one? Why is this one not like the others that we did? Nathan?
Because you can't even divide it.
Yeah, because the only common factor between 6 and 11 is 1. So remember, we put our, oops, I just messed that up.
I got it right.
How do you know? We haven't talked about it yet. 1,
Possible.
okay. So if it's 1 and done, then our greatest common factor is just 1. And the reduced fraction is 6/11. In other words, it won't reduce. That's what that means. It won't reduce. Okay? All right.